Welcome to qnawire.
So we're given that we have two masses, mass A and mass B, and then we have a third mass up here, mass P, and we want to know what the net acceleration is on it due to the gravitational force from masses A and B. So right away, we can see that there's going to be no total force in the x direction, and that's just due to the fact that this is all symmetrical here, and mass A and mass B are the same. So mass B will be putting some rightward force on mass B, but then mass A will put on the exact same force, just in the opposite direction. So we can say that in the x direction, the net force has to be 0. And so that tells us that the x component of the acceleration for mass P is also 0. So that leaves us then with just finding the y component of the force. So to do that, we want to look at each of these masses and find the gravitational force just in the y direction. So we have our gravitational constant g, we have mass of A, we have mass of P, and then we have the distance between the two, so RAP squared. And then because we only want the vertical components, we need to take, in this case, cosine of our angle theta here. So cosine adjacent or hypotenuse, so that'll give us adjacent this vertical part of the triangle divided by hypotenuse. So as we've defined theta here, that'll be the vertical y direction component. So that will be the force from mass A, and because mass B is the same mass and the situation symmetrical, it should contribute just an identical term. But for completeness, we'll write this, and so exactly the same, except it's mass B now. Mass P, cosine of theta again, and divided by the distance between B and P squared. So let's find what our theta is going to be really quick. So they give us most of the dimensions of the triangle here. So we could find theta in a number of ways. I'll just do arc sine of theta here. So sine opposite or hypotenuse. So if we take inverse or arc sine of that, we have 8 over 10. And we should find that that is about 53 degrees. So now we'll be able to use that theta plugging into our equation for the force in the y direction. So we have all of our mass numbers, and so when we evaluate this, we should get that each of these two terms are 1.04 times 10 to the negative 11th newtons. So we have one of those and then a second one. And so now we can find the total y force then, and so that looks like it should be 2.08 times 10 to the minus 11 newtons. And then we just want the acceleration, so the acceleration will be that force divided by mass p, and really this is the acceleration in the y direction, though this will also be the total acceleration here. And so we can solve for that, and we should get 2.1 times 10 to the minus 9 meters per second squared. So very small value, especially compared to the acceleration due to the Earth's gravitational field here. So this is something that we could typically can ignore, but this would be measurable in some cases.